All right, so a couple weeks ago, as I said, we looked at solving triangles, right, which means finding out how big the sides are, how big the angles are. When we did it a couple weeks ago, every triangle we worked with had a right angle. They all had a 90-degree angle. This week, the triangles are not going to have that. If they do, then it's just a coincidence, but most problems are not going to have a 90. If you have a triangle that doesn't have a 90-degree angle, it's called an oblique triangle. And there's really two types of oblique triangles. You can kind of separate it into two categories. And I drew a picture of each type. So one type of triangle that doesn't have a 90 is an acute triangle. In an acute triangle, all the angles are smaller than 90. A specific example, think of like an equilateral triangle, 60, 60, 60. Okay. Another type of triangle that doesn't have a 90 is an obtuse triangle. Okay. In an obtuse triangle, there's exactly one angle that's bigger than 90. Could you have two angles that are bigger than 90 in a triangle? You think, no? How come?
Because it wouldn't have a close 180.
Right. Even though we don't have a 90-degree angle, all the angles still have to add up to 180. So you couldn't have two that are bigger than 90. Okay, only one. And that's an obtuse triangle. Regardless of what kind of triangle we're going to draw, my sketch is going to pretty much look the same all week. So I'm going to show you the diagram that I'm going to use all the time. Keep in mind that my diagram, as always, it's not going to be to scale. Okay. What's important is the labels. So when we're talking about the sides and the angles, we have three sides, three angles. So that gives us 6 different things we have to name. For the sides, we're going to stick with what we always have, ABC. The only difference is C is no longer a hypotenuse. Okay? Because to have a hypotenuse, you have to have a 90. No 90, no hypotenuse. So the sides are A, B, and C. We always put Greek letters for the angles. So that just avoids confusion between using like capital letters for angles and lowercase letters for sides. That can get kind of tricky, especially if you had like a capital C and a lowercase c. They could look the same. So we use Greek letters for angles. 2 weeks ago we had alpha. Alpha is always opposite A. Beta is always opposite B. But now we've got this new Greek letter right there. How come I never had to name this angle before? 2 weeks ago, that angle was always what?
A 90.
It was always a 90, so you didn't have to give it a name. We just said it's the right angle. Well, now we're going to call it gamma. G-A-M-M-A. That's gamma. And gamma always goes across from C. You can flip this triangle, rotate it, do whatever you want to it, as long as you always keep A across from alpha, B from beta, and C across from gamma. Okay? But that's usually how I sketch it. All right, so there's always 6 things in a triangle, but to solve it, I have to give you 3 of them. Depending on what I give you, out of the 3 angles and the 3 sides, controls whether or not you're going to use one of 2 laws we're going to learn. Some information requires you to use law of sines. Different kinds of problems require law of cosines. Okay, law of cosines is going to be what we do on Wednesday. One type of problem that requires law of sines is if you're given 2 angles and a side. So that's what they would start you off with in the problem. 2 angles and a side. And even within that, there's 2 ways they can do that. ASA and SAA are two different types. They both have 2 angles and a side, but here's the difference. Okay, the one on the left that says ASA, just look at the placement of the S. The S is between the 2 A's. The side is between the 2 angles. Well, in the example on the left, the side that's 3 units long is between the 2 angles. It's the side that connects them. In SAA, you still have the same pieces of information, 2 angles and a side, but look where the S is. The S is not between the 2 angles. So in this case, the side that's 4 units long is not the one that's connecting the 2 angles. If you knew the bottom side, that would make it the other type. Okay? This time, if you know this side, or if you know this side, those are both sides that aren't between the angles, and that makes it SAA. So you've probably seen those when you did proofs in geometry. We're not using them to do proofs, we're just using those abbreviations to describe the information that you're being given. Okay. Any questions on the difference between ASA and SAA? Okay, but both of them are 2 angles and a side. So that's one big case with kind of 2 smaller cases that you use law of sines for. And the other case that you use law of sines for is SSA. Okay, that's different than the other one because now you're being given 2 sides and an angle. And notice the placement of the angle. It's not between the 2 S's. So we know a side, and then we know an angle, but it's not the angle that's where the 2 sides meet. That would be this one. We know an angle that's not between the 2 sides. Okay? Either the one that I labeled, or if you knew that one, that would still be SSA. Okay, as far as abbreviations, ASA, you can write it forwards or backwards. It's really the same thing. If you write AAS instead of SAA, that's fine. SSA, I prefer you write it in that order. It's just nicer. Okay. We'll be polite. Okay, so to solve any of those 3 types of problems, we're going to use the law of sines. So now we'll kind of go through a little picture and figure out what the law of sines is. Once we figure it out, we're never going to have to figure it out again. It's going to be a formula. You just write it down, and you just use it, and just plug into it. But on the test, this is the first thing you'll have to decide. Is my triangle that I'm trying to solve one of these 3 types? If it is, I'm going to use this law. If it's not one of those 3 types, it's going to be a different law. Okay. And you can't really mess it up, because if you try to use the wrong one, you're not going to have the right stuff to plug into it. You're going to try, and you're going to be missing too many things. Okay. But it's still good just to know which one to use. All right, so let's look at this. So I'm going to start with just kind of a generic diagram. It shouldn't look like any of the sides are the same. I tried to make it look scalene. So sides are all different lengths. Angles are all different. And I didn't label all the sides. I only labeled 2 sides and 2 angles. That's because to do what I'm about to do, I don't need the 3rd side or the 3rd angle. Okay, what I am going to do, though, is separate this picture into 2 right triangles. Okay, the way I'm going to do it is I'm going to put in an altitude, or the height, from that top angle down to the bottom. Now, you could do this from any side. You could draw in the height from any of the angles. It's just simplest to sketch if I draw it from the top. Okay? And that's a 90-degree angle, which also means that's a 90. Okay. Any questions on what we've done so far? Since that's the height, I'm going to call it H. H could be confused with hypotenuse, but just remember H in this case stands for the height. And what I'm going to do is I'm going to look at this picture 2 times. I'm going to block off what's on the right in a second, and we're just going to focus on the left side, and then we'll look at it the other way. Okay, so let's just kind of forget about what's on the right for now. Okay, so I'm focusing on that right triangle on the left. in that triangle, I have two sides named. I've got H and B. If you're standing right there, okay, from the perspective of that spot, what's the name of the side that's labeled H? Is that opposite, adjacent, or hypotenuse? The side that's labeled H.
Opposite.
So we have opposite. And we've got one other side, B. Jordan, what's the side that's labeled B?
Hypotenuse.
It's hypotenuse, because it's across from the 90. Now, out of the three trig functions, sine, cosine, and tangent, there's one of them that would involve opposite and hypotenuse. Does anyone remember which trig function has opposite and hypotenuse? Yep.
Sine.
Sine. So what we're going to do is we're going to set up a formula using sine. So the sine of my angle equals opposite over hypotenuse. It doesn't matter that these aren't numbers. Okay, that's good, because we're just doing this in general. So Brady, if it's opposite over hypotenuse, what would go on top and what would be on the bottom?
H would go on top and B would go on the bottom.
Yep, H over B. Okay, now what I really want is H by itself. Okay, so I'm actually calculating, or I'm coming up with a formula that calculates the height. So how would I move the B over to the other side? Oh, cool.
Multiply by B.
Exactly, just multiply both sides by B. And now you have a formula for the height. So if I gave you alpha and I gave you B, all you'd have to do is plug them into that formula and you could find the height of that triangle. Any questions on that box? Okay, just to give that a name, let's call it box 1. Okay, we're going to do box 2 right now. To do box 2, I'm going to look at the other side. And I'm going to do exactly the same thing again. I'm just going to block everything that's on the left and focus on the right. My goal is to calculate another formula for the height. This time I want to use this stuff. Okay, so we'll go through, figure out the names of the sides, and then go from there. Cassandra, from the perspective of beta, what's the name of the side that we labeled H?
Opposite.
It's opposite. A is across from the 90, so A is the hypotenuse. It's the same two names we just used, opposite and hypotenuse. So we're going to do sine again. So the sine of my angle is opposite over hypotenuse. And Ethan, what would that be in this case?
A.
Well, we need a fraction.
Oh. A over H.
That would be your cosecant. Lauren, can you remind me again, what's sine?
Opposite over hypotenuse.
Opposite over hypotenuse. So Cassandra told us H was opposite, and I told you A was hypotenuse. So it's H over A. I want to do the same thing I did and get H by itself. So Sam, can you tell me what H would equal for the right-hand side?
A sin beta.
A sine beta. And we just call that box 2. Okay, so now let's look at what we have. Box 1 is a formula that calculates the height. Box 2 is a formula that calculates the height. What does that mean if you compare box 1 to box 2? If you had actual numbers and you plugged them all in, what would happen between the value in box 1 and the value in box 2? Oh, Lexi? You get the same number, right? Box 1 calculates the height, box 2 calculates the same height. It's not a different height, they're both calculating the height. So box 1 and box 2 give you the same number, so that means box 1 and box 2 are equal. Okay? So now we want to kind of set up that idea. And that's the whole point of the law of sines, once we plug in box 1 and box 2 into this equation right there. Okay. So we've got b sine alpha equals a sine beta. Now the last thing that they usually do when they write the law of sines, to just kind of put some things together, is they put a over with alpha, and they put b over with beta. So Carissa, if I wanted to put a over with alpha, how would I move a to the left?
Subtract it. Or no, you divide it.
We divide it. Yeah. If this was an addition sign in there, then we would subtract it. But since it's a multiplication, we divide it. So I divide both sides by a. And Carissa, how would I put the b over on the other side?
You would divide.
We would divide. So we're dividing both sides by ab. Here the b's cancel. Here the a's cancel. And that is the law of sines. The law of sines actually has 3 fractions. I think if I write out the first 2, like I have right there, you should be able to see a pattern and guess the third one. So it starts out with sine of alpha over a equals sine beta over b. Does anyone have a guess what the third fraction is?
Sine gamma over c.
Sine gamma over c. Yeah, we didn't prove the last part, but that's where I said to you, you could draw the height from a different angle instead of the one at the top, and you could do the third part just like we did the first 2. And that's the law of sines, which I'll just abbreviate LOS. Okay, one thing that's important to understand is when you use this formula, you never use all 3 parts at the same time. You're either going to use the first 2 fractions, the last 2 fractions, or the first part and the last part. So you pick 2 out of 3 of the fractions to use. Kind of like we did last week. When we're solving a problem, we'll make a table. We'll put the 3 sides in one column, 3 angles in the other. And that's just to kind of organize our information. Okay, a couple things to remember. You cannot use the Pythagorean Theorem anymore. Okay, Pythagorean Theorem only works when you have a right angle. So unless I give you a problem with a right angle, you can't use it. Okay. What you can still use is the fact all the angles add up to 180. Okay, that's still true. So if you know 2 out of 3 of the angles, you can add them up, subtract from 180 to get to the third one. When you use the law of sines, what's going to happen is you're going to have a fraction equal to a fraction. Okay? Every problem is going to look something like this. Just to show you kind of simpler numbers without decimals, I'm just going to make some numbers up. 3, 5, x, 10. That's basically what every problem is going to look like. You're going to have numbers in 3 spots. You're going to have a variable in one of the other spots. It could be in the top, it could be in the bottom, but you'll have 1 variable and then 3 numbers. Does anyone remember what that's called? This kind of problem, a fraction equal to a fraction? Begins with a P. Yeah?
Proportion.
It's a proportion. So every law of sines problem is a proportion. And does anyone remember how you solve a proportion? How do you do that? Yeah? You cross multiply. So in this problem, you get 30 equals 5x. And then the last step would be to divide by 5 and get 6 as the answer to that problem. Most of the ones we do, you'll need a calculator because it's going to involve sign, so you're going to get decimals. But you still cross multiply. Okay. And as far as explaining things to you, that's it. So we'll look at 3 examples. for law of sines today, and then we'll look at some other cases tomorrow. All right, so the first thing it says, solve the triangle. What you need to decide right now is which law you need to use, law of sines or law of cosines. Obviously, I haven't taught you law of cosines yet, so we already know which law it is, but it's still good just to make sure we know why, because on the test, they'll all be mixed up. Easiest way, if you're not sure by looking at the information, is to make a sketch. I'm going to put A across from alpha. So you have to do that. I'm going to put B across from beta. I don't know B, so I'll just call it B. B across from beta. And I'm going to put C across from gamma. And I don't know either one of those. Okay. Now I look at the information I'm given. I have an angle, and then a side that's not the one connecting the two angles. C is the one connecting the two angles. So this is angle, angle, side. Or side, angle, angle. If we go back in our notes, it's that type right there, which is one of the three types we use law of sines. Okay, so what I've done is I organized that information into a table, 3 columns. The 3 sides are in one column, 3 angles in the other column. Now, another way you can tell it's a law of sines problem without having to make a sketch is, let's go back and look at the formula. In order to use law of sines, you have to know 1 out of 3 of these fractions completely, top and bottom. So you either need to know this entire fraction, which means you have to know alpha and A, okay, that fraction, which means you have beta and B, or that fraction. 1 out of 3 of the fractions, you have to know everything. What does that mean in terms of setting it up in this table format? You have a row that's complete. If you have a row that's complete, like in this case the first row, that means you know 1 of the fractions completely. And that tells you it's law of sines. Okay, so a complete row in the table. If you're thinking, well, wouldn't you always have a complete row? No. If I gave you a side, and a side, you would have a complete column. You'd be missing every angle. So if you know side, 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 that is not something you know how to solve yet. We're not going to do that today or tomorrow. Same thing if I gave you a side, angle, side, SAS. You would not have a complete row. You can't use this to solve it. All right. So in this particular problem, there's something here that's probably the easiest thing to find. We don't really need law of sines to do it. Anyone think they can tell me what's the quickest thing we could find here? Yep.
Gamma.
Yeah, we can get gamma pretty quick because we already have 2 angles. So we're going to add them up, subtract from 180. And what do you get for gamma?
80.
80. Okay, so now we have all the angles. From this point, you can find B or C. It doesn't matter. Okay. We know the angle across from B. We know the angle across from C. So we have enough information to find both. This is going to be the key row that we use to do everything. So let's find B first. I'm going to start with the top row. That's the A and the alpha. So I'm going to fill in to that fraction. Sine of alpha over A. So sine of 40 over 4 equals, and if I want to find b, I'm going to use the part of the law of sines that has b. Sine beta over b. Sine 60 over b. And notice 3 out of 4 of the spots are all numbers, so we'll just cross multiply. Get b by itself, then we use our calculator. So you've got 4 sine 60. Don't even do out 4 sine 60, just leave it like that. Okay, we will do it out at the very end. And b sine 40. Okay, any questions up to that stuff? Okay. The last step now is to get b by itself. So we're going to move sine 40 to the other side. Ryan, how would I move sine 40 to the other side?
Divide by 7.
Yep. Again, don't even worry about what it is. Just divide each side by it. So sine 40 over sine 40 cancels out. And there is your answer for b. So notice as I did that, I didn't do any rounding. The only rounding I'm going to do in this problem is right now, the very last step. Okay, so now we'll type it in. If you're using a calculator, that can be in radians or degrees. Make sure it's in degrees. Okay, I know last week we did radians when we did graphing. This week everything is going to be degrees. Okay, so we got 4 sine 60. Notice my calculator automatically opens a parenthesis. You're going to have to be careful. So if your calculator does that, you're going to have to put in the appropriate closing parenthesis. Okay? So 4 sine 60. I have to close it because now I'm done with the top. Divided by sine 40. Divided by sine 40. Not a big deal if I close the 41 there because I don't have anything else coming after it. So if I close it, if I don't close it, I'm going to get the same answer. But it's very important to close the one after the 60. All right, so we get 5.389. Okay, so now we know 2 out of 3 of the sides. Yeah.
It's probably a dumb question, but why did you use gamma when we were trying to find b? Like, why did you say a sine of 80 over...
Did I do 80? I shouldn't have done 80 if
No,
I
you
did.
didn't, but like, why didn't we use that?
Because you use beta to find b, you use gamma to find c. You always use what's across from it.
Oh, okay.
Now we're going to use gamma to find c. All right. Now, one thing we have to be careful about is if you look at gamma, was gamma given to us or did we find it? Okay. We found it. So 2 weeks ago I said to you, if you found a piece of information, don't use it to find something else. Because if you found it and it's wrong, then whatever you use it for is also wrong. Well, this week there's no way to avoid that. You're going to have to use pieces of information you find to find other things. So if you made a mistake with gamma, you're automatically going to get C wrong as well. But at least B was separate. Okay, we didn't use gamma to find B. So you could still get B right even if you made a mistake on gamma, because gamma has nothing to do with B. So now let's set it up to find C. Now, I told you have to use a row that has everything in it. Technically, we have 2 rows that have everything in them, the first one and the second one. So you could use either row. But Kyle, which row do you think would be better to use?
Second one.
How come? All right, so Kyle thinks the second one, but he's not sure. Does anyone have a different opinion or can say why they agree with his opinion? Yep.
The first one,
First one. How come?
because we already have everything right there.
But we have everything right here too, right? I mean, we have that, we have that. It's all there.
Because 40 is a multiple of 80.
That's true that 80 is a multiple of 40, but that fact doesn't really have anything to do with why I would pick the first row. But that is a true fact. But, yep.
Because it was given to us.
Yes, because it was given to you. So we know everything in the first row is right. There's no decimals involved. That's going to be much quicker to type into the calculator than 5.389. Okay? Because if we made a mistake on B, let's say we got gamma right, well now you get C wrong if B was wrong. So just stick with using as much given information as you can. So we're going to set it up the same way. Sine 40 over 4 equals, and this time we're going to use sine gamma over C. Sine 80 over C. Now, after you do a lot of these, the cross multiplying kind of gets just pretty routine. So if you want to jump right to this step, that's fine. If you want to do the step in the middle, bless you, like I did last time, that's fine too. But the final answer would be 4 times sine 80 divided by sine 40. You would have to divide by sine 40 because it would be C times sine 40. You don't want C times something. You want to get C by itself, and division would move it to the other side. And that's C. Any questions on what we need to type in for C? Okay, don't try to do anything fancy like say, 80 divided by 40 and simplify it. Just type it in exactly the way you see it. Okay, you can't do anything with that. Just use your calculator. All right. Also, a lot of the calculations you type in are pretty repetitive. So if you can bring up the last one you typed in, usually you only have to change one number. So this is 4 sine 80 divided by sine 40. Okay, or if you don't have that, just type it all in again. Okay, before I hit enter, one thing I can tell you is that gamma is the biggest angle, so C should be the biggest side. So it has to be bigger than 5.389. But C can't be bigger than 9.389, because I know if I add any two sides together, it has to be bigger than the third. Okay, so I know that C is somewhere between 5.3 and 9.3. Okay, we'll hit enter, and it comes out 6.128. And that's a law of science problem. It seems like it took kind of a while, but I could go through that a lot faster if I wasn't trying to explain everything as I'm doing it. And I'm sure once you do a couple of them, they are a little bit faster. Okay. Any questions on that? As far as rounding, I think sticking to 3 decimal places for whatever you calculate is pretty good. Unless it comes out exact, like 80, you could just write 80. Okay. So that's the angle side. Let's look at this one. So this one is still 2 sides in an angle, but this time the side is the one between the angles. Last time it wasn't. Now, in the last problem, technically, we didn't have to find gamma first, because gamma had nothing to do with B. Okay, you have to find gamma before you find C. But if you wanted to find B first in this problem, you could have. I did gamma because it was easy to find. Here, if we look at the information, Tanner, do I have a row that's complete? No. I told you in order to use law of sines, you have to have a complete row. So what we're given right here, there's no complete row. But can we find something that would give us a complete row? Yep.
Gamma.
Gamma. We can find gamma, then we'll have a complete row. 45 and 40 gives me 85. So how big would gamma be? Yep.
95.
95. Now, in this problem, it's really important you get gamma right. Why is it even more important in this problem that we get that angle right than it was in the last problem? Yeah?
So, because if you get it wrong, then everything's wrong.
If you get gamma wrong in this problem, it's all wrong. Because this is going to be the important row we use for everything. Okay? If you got gamma wrong in this problem, yeah, you're going to get C wrong, but you could still get B right. Because you were using a row that was given to you that had all the important stuff. This time, you weren't given a row with all the stuff. You had to find one. So just add it up carefully and don't get gamma wrong. Okay. All right. Now, at this point, we can find A or B. The order doesn't matter. All right, so, Brady, you want to find A or B? B. All right, so find B first. So what I like to do is just set up my proportion, and then I'll fill everything in. Austin, can you tell me what would go on the left-hand side?
Sine 95 over 40.
And if you're thinking, well, could he have put that on the right-hand side? Sure. You got to put sine 95 over 4 on one of the two sides, and then the other thing you want to find on the side you didn't use. So, Marisha, what would go on the other side? And we're going to find B. Well, what do I have to put in the top part? Forget about the bottom for now. So the trig function always goes in the top. Okay, so whenever we're dealing with the formula, sine is always in the top. And in this case, it would be the sine of... Well, what are we finding?
I really have no clue.
Right here. We're finding B.
A 40?
The 40. So you always use the angle. Remember, you always use the angle that's across from the side. Okay. If anybody's unsure, ask me a question. Okay, Kyle, what's going to go in the bottom?
Gamma.
Well, gamma we've already used for the 95, so that's done. The whole bottom row is used up. What are we finding?
B.
B. So we have numbers in all three spots. We've got to have a letter somewhere. The letter we're finding is B. There's only one spot left to put it. Here's our letter. Okay. Any questions on setting up our proportion? Yeah.
This is the capital B stand for.
Capital B? Oh, beta? That's beta. It stands for beta. So the three angles on the right-hand side are Greek letters. Yep. All right, so now we've got our proportion set up. Sean, how do I solve a proportion?
Cross multiply.
Yep, cross multiply. So you're going to get B sine 95 equals 4 sine 40. Now, if you want to write that step down that I just said, that's fine. Or if you jump right to the last step, that's fine too. Maybe I should write it down. So we get B sine 95 equals 4 sine 40. Okay, if we write that down, now we still have one more step to get B by itself. Abby, can you tell me my last step to get sine 95 on the other side?
You divide both sides.
Yep. Divide both sides. Don't worry about what the sine of 95 is right now. Okay, we'll do that at the end. And there's our answer for B. We have to type that. Any questions on that? All right, so now we'll type it in. I can't really tell you too much about it. I know it's going to be less than 4, but other than that, I don't know too much more. So if I get an answer that's like 107, then I know I typed something in wrong, or maybe I'm in radians instead of degrees. So I'll just double check it. All right, so we got 4 sine 40. Make sure you close the parenthesis. If you're not sure on your calculator, just ask me and I'll help you before the test on Friday. Okay, so we get 2.581. Okay, now I have 2 out of 3 sides. Can I use Pythagorean Theorem to get the third side?
No.
No, why not? Yeah.
You don't have 90.
I don't have a 90. This isn't a right triangle. It's close. So if you use Pythagorean Theorem, your answer will be close, but still wrong. So don't use Pythagorean Theorem. I know that it's going to be, well, alpha is 45, beta is 40. So A is a little bigger than B. Maybe it's like 2.6, 2.7. So that's roughly where I should be expecting my answer. Okay. So take a second, see if you can just set up the proportion yourself. If you have a calculator, you can solve it. If not, just try to get to the step with the box around it, where we need to plug everything in as the last part. Okay, so like last time, we've got 2 rows now that have everything in it, so you have an option of which row to pick to find A. Kyle, which row should I pick that has everything in it? Row 2 or 3?
3.
Why?
Because you found that one first, whereas the second row you found the second. So if you have the third row wrong, that would make the second row wrong as well.
Yeah, so at least with the third row, we don't have any decimals. Okay, so it's good, 95. We found that one right away. We only did 1 calculation to find 95. We did 2 calculations to find B. First, we found 95, and then we used it to find B. So either row is going to involve something you calculated. One of them is something you really only did 1 step for, and then the second row, you had to do another calculation. So let's stick with gamma and C. So we'll start with sine 95 over 4. So sine 95 over 4. And now, to find A, you always use the angle that's across from what you want to find. Sine 45 over A. Okay, and can somebody tell me if I get A by itself? You don't have to give me a decimal. A would be just what times what divided by what?
4 sine 45 over sine 95.
Yep. Perfect. Okay, and that's A. Does anybody have the decimal for that? Again, I'm guessing it's a little bigger than 2.5, probably 2.7.
2.839.
2.8, okay. 2.839. Everything looks good. So any questions on that one? Okay, so we're just really doing 1 of each type. We're not doing like 3 or 4 of the same type. So there's your ASA. That's angle side angle. Okay, so the last type. Okay, I already have a sketch so we can see which type it is. We've got 2 sides and an angle. The angle that you know is not the one between the 2 sides. If it was, you wouldn't be able to solve it today. Unless you know things that I haven't taught you. Which, hopefully you know something that I haven't taught you. But you probably don't know the law of cosines. So, this is the type that's side-side angle. 2 sides, and the angle is not between the 2 sides. Side-side angle is the trickiest case that we have to deal with. It's the trickiest case out of everything we learned today, everything we do tomorrow, and everything we do on Wednesday. because something can happen here that can't happen anywhere else. So with side-side angle, you could end up, it's a problem just like we've been doing. You solve it, and there's one solution for everything. So when you find C, you get one number. When you find beta, you get a single number. When you find gamma, you get a single number. Okay, worst case that would take the longest is there are two answers for everything. So when you find all the things I just said, there are two possible numbers for each one. So in that case, there's three things to find, two answers for each one of them. I'd be looking for 6 answers. Okay. Kind of the best case or the shortest case is when there's no solution. Okay, you try to start solving it, you realize right away the information they've given you is impossible, it doesn't work, and then there's no solution for any of the 3 things you're missing. Okay, so today we'll focus on one of those 3. Either the 1 solution, the 2 solution, or the no solution. And again, this stuff only comes up with side-side angle. So put an asterisk next to side-side angle or underline it, or just remember this is the one that's a little tricky. Okay, so let's solve them. So I took the same information you had up above. I just put it in the table like we've been doing. Now, what can't you do here that you could do in the last 2 problems right away? Yeah.
Find the third angle.
Find the third angle. You can't find the third angle because you're missing 2 of them. In each of the other problems, we were only missing 1. So that's a little different. You can't find the third angle right away. Can I use Pythagorean Theorem to get C? No? How come that?
There's no 90.
There's no 90. If you use Pythagorean Theorem to get C, you're assuming gamma is 90. We don't know what gamma is, so we can't use Pythagorean Theorem. So, out of the 3 boxes that are empty, there's only one of them that you have enough information to actually find. The other 2 boxes we have to ignore for now. Anyone think they know which box, beta, C, or gamma, we have enough information to try to find?
Beta.
Beta. If you have a row that's empty, ignore it. There's nothing you can do with an empty row. Okay? You have law of signs, you either have to have everything in the row or at least something in the row. Empty row, no good. So we're going to have to come back to finding that stuff later. So the first thing we're going to find is beta. I just put a 1 next to it, so when we're done, you can see the order that we went in. All right, so we'll set it up, just like we always do. Row 1 is the important row. It's got everything in it. So sine 40 over 3 equals sine beta over 2. Now, before we even go any further, if you look at that, there's something different about this. There's a lot of things different about this type of problem, but did anybody notice where the variable is this time compared to where it was before? Sam?
Beta. This is like on the second one.
And what is beta? It's an angle. Okay. Every time we did this before, B, that's a side. A, that's a side. Okay. The problem before that, B, side. C, that's a side. We always were solving for a side. We've never had to solve for an angle. Well, this time we do. So we're going to cross multiply, just like normal. So 2 sine 40 equals 3 sine beta. Okay, I want to get the 3 on the other side, so I'll divide by it. And that still doesn't get beta by itself, but at least it gets rid of the 3. So now on the right, I have sine beta, and on the left, 2 sine 40 over 3. Okay, so now my goal is to get rid of sine and get beta by itself. How do I get rid of sine? And this is what we did last week.
Inverse sine.
Exactly, inverse sine. Take the inverse sine of what's on the right. Take the inverse sine of what's on the left. Inverse sine, regular sine, cancel each other out. On the left, there's nothing you can cancel because you have a division, you have multiplication. Just leave the left-hand side alone. That's how you have to type it in. It's a little more complicated with parentheses if you're going to type it in all at once, but I will show you right now. So it's inverse sine. So start with that. And it's going to open a parenthesis for me. So when I'm done with inverse sine, I need to close it. So inverse sine of 2 sine 40. Notice it opened a parenthesis for sine. Once I type in 40, I'm done with it. I'm done with sine. I need to close the parenthesis for sine. Divided by 3. Close the parenthesis for inverse sine. So I have 2 opening left, 2 closing right. That's how you type it in. Okay. And if you type it in correctly when you hit enter, you should get 25.374. Now, what I'm going to do is I'm going to put that answer in the box. But notice how I did it? I wrote it up a little higher. The reason I did that is because if there's a second answer, I'll put it down below. Okay? If there's not, then there's not. Any questions on how we got 25.734? All right. So this is the kind of problem where now there's one extra step. We have to check if there's a second answer.
It's 374.
Oh, 374? Thank you. Yeah, it should have been 374. That wouldn't have messed us up a lot, really, but the rounding would have been kind of messy, so try not to switch your digits. Okay, it's very easy to check if there's a second answer. You're going to take the answer that you just got, 25.374. In our case, that was beta, but it doesn't matter, whatever you're solving for, beta, alpha, gamma. Take the answer you just got and subtract it from 180. Okay, let's do that. So let's take the answer we just got and subtract it from 180. On my calculator, I can just do 180 minus the last answer that was on the screen. And I get 154.626. I'm not going to write that in the box here. Okay. If there's a second answer, that's what it would be. 154.626. I'm just going to write it off to the side and I'll come back to it. Now we have to see if it's possible for an angle that's that big to fit in the triangle. Because remember, we were given an angle to start. We already know there's a 40. So whatever else we're trying to fit in there, we're limited to 180. Okay? So see if it's possible to fit the answer we just got, which was 154.626, and the angle they gave me. Okay? They gave me a 40 in the same triangle. Okay. So in our case, would a 154 and the angle that was given, 40, would those fit in the same triangle? No, it's too big. So in this particular problem, the second answer is too big. We can ignore it. We don't need it. We can finish this just like a normal problem. Okay, so you got to go through and use your trig, specifically inverse sine, to get the answer first. then subtract it from 180 and see if that would fit in the triangle. Yep.
How did you get that 150? Did you just subtract 25 degrees from 180?
Yep. I did 180 minus the 25.374.
And that's how you got the second answer?
Mm-hmm.
Alright.
And then I read the rest of it, which says, would 154 and the angle that was given fit in the same triangle? Nope. 154 plus 40, it's 194. It's too big. Okay. So I don't need it. If it worked, what I would have done right now is I would have written it down in the bottom of that box and then continued from there. Yeah, I'll show you that part tomorrow. Okay, so then I just explained what we just said. You don't have to write this part down. So I showed the 180 minus the 25. We got 154.626. We were given a 40. If you add up what we were given, it's more than 180. Okay, too big. So that's the reason the second answer doesn't work. Okay, so any questions on how we got the first answer, how we got the second answer, and then how we figured out the second answer in this problem? We can ignore it. All right. So now from here, we can finish it just like normal. We've got 2 out of 3 angles. Now we can add them up, subtract from 180, and now we can finally get gamma. So that's 65.374. We know all the angles. I have to add up to 180. So subtract. Okay, so gamma is 114.626. Now you can finally do something with that last side because you have a piece of information in that row. You've got gamma, now we can find C. Do you have to use gamma to get C? Yep. So even though you calculated, you have to use it. Okay, but besides using row C, what other row should I stick with here? Yeah, stick with row A because it was given. There's no decimals. It's a better option. Okay, so let's find C. To find C, it's going to start out just like we did to find beta. Sine 40 over 3. So left-hand side is the same. But now if we want to find C, use gamma. Sine 114 over C. Okay, if you're rounding everything to 3 decimal places properly, your answer shouldn't be that much different than mine. So, whatever we get here, I'll kind of explain to you what I would accept on the test. But if you're going to 3, we should both be pretty accurate. All right, so I need 3 sine 114.626. And divide by sine 40. Okay, so the answer is 4.243. If you had 4.25, that's fine. If you had like 4.22, that would be okay. If you had like 4.5, that's, or even 4.4, that's, for rounding to 3 decimal places, that's kind of far off. Okay, so 4.25, 4.27, 4.22, anything around there would be fine. And that's C. Okay, so that's the side angle type. Okay, worst case to deal with, but tomorrow we're going to spend the rest of the time just on this one case, looking at the 2 solution and the no solution. Homework tonight, it's all odds. On 266, 9 to 13, 17 to 21, and 25. Okay, so we'll finish law of sines tomorrow, Wednesday. If everything goes well tomorrow, we should do law of cosines. Thursday would be review. Friday, last test for the term.